So pointer in C, we have two types of data type. One is the primary and another one is the secondary data type. Primary, that means it's a integer, character, float, double, all are the primary data types. Secondary are the pointer, array structure, union, enum, type def. So secondary data type are derived from the primary data type only. So we have started pointer. Pointer is one of the secondary data type which is useful for storing the address of another data type through which you can access data indirectly. So main use case of pointer is storing the address of another data type and through which you can access the data indirectly. Means you can copy that data, you can modify that data, you can store that data to somewhere else. Like this way we will use that. So indirectly we will use another data types data. So it is generally using the call by reference in the functions. We will see dynamic memory allocation, file handling, data structure, all the concept. So this is the basic syntax. Data type star variable name. Star, that means it's the pointer. So here integer pointer, character pointer, float pointer. So whenever we will write integer I, so I is the variable. So it will store the value directly. When we use pointer, so it will store the address, not value. And we have seen one example. So we will continue on this new program p44.c. So this is my integer pointer I will take. One character pointer I will take. Character is equal to a and one character pointer. Float is equal to f is equal to 5.3 comma float pointer. So I will do IP is equal to address of I, P is equal to address of CH, FP is equal to address of F. Here we are storing the starting address of variable. So starting or address of variable is, so my data 10 is stored in the I and ith location is 1000. Then CH location is 1004. Data is A, plot F, location is 1005 and 5.3. So this is for example. Not every time our data is stored in contiguous manner. So here this is my 4 byte, this is my 1 byte, and this is my 4 byte. Now I will take integer pointer. This is my integer pointer. Here at store I have stored the address of I. That means 1000 location is stored. What is 1000 exactly?
The value of the address?
This not value, this is the address.
Yeah, address.
Yes.
I mean, the address where that variable is located, right?
Yes. So in
Yeah.
our
Mhm.
memory, so suppose you have a system is 64 bit. So 64 byte. So like this way 32 and 64. We have two types of system we are using in Windows. So this depends. 32, that means you have a 32 bits of addresses. 4 byte address, here 8 byte address. Understood that because of that reason this is the difference yet. So in microcontroller there is a 8 bit, 16 bit, 32 bit. So this is the address range.
Got it.
So next character pointer. Character pointer is stored the address of CH 1004. Float pointer stored the address of F is 1005. So now you tell me what is the size of integer pointer?
I think it should be four bytes.
Yes, 4 bytes.
What is the size of character pointer?
One. I think a character will take only one byte, right?
Yeah. So character size is 1 byte. That for sure. Here
Mm-hmm.
pointer role is it is storing the address, not character.
Mm-hmm.
Oh, makes sense. Okay.
Okay.
4 byte.
Yes, exactly.
Hmm.
Here also 4 byte.
Same.
Four.
So here character pointer is storing the address and we have the address size we have to access data indirectly, that the star ch we will use star cp.
Hmm.
But cp itself it is storing only address. Okay, write down this. So address size is depends on the OS. If you have a 32-bit system, then 4 byte. If you have a 64-bit system, then it's a 8 byte, like this way. Printf the d percentage d slash n. Here size of I, size of ch, comma size of f. Then I have to put here slash n. Okay. Then I will copy this. I want size of IP, size of CP, and size of FP, size of star IP, size of star CP, and size of star FP. So size of I, what will be the output here?
Should be 4,
Okay,
right?
4 byte. Yes, yes.
Here,
Yeah, it's 4.
size of CH,
Mm-hmm.
1.
4. Here
Yeah,
IP 4, CP
4.
4, 4. What is the star IP?
Star IP is the I mean address of that that variable, right? Should be 4.
Value of that.
Value. Yeah, yeah. 4.
Here normal IP that address, star IP
Mm-hmm.
that the value. So here star CP,
1, 4.
and what will be the output here?
Star IP. Okay, so I think it should be able to
10.
print the variables, right? It should be 10, A and 5.3.
Yes.
Okay, I will run this code. Okay, so 414, 444, 414, 10A, 5.3. Okay, so write down this code. If you want to print the address of I, address of CH, and address of F, so you can like do like this way. Printf %d slash n, comma, address of I, address of CH, address of F. So here it will print the address. So whatever address assigned in my system, it's different. In your system is different. So it will not same. It's a random address will assign a variable. Wherever the space available in my RAM, that address will assign. So this is the address. Okay. So this is not always in contiguous manner. See this code. Address of I, address of CH, and address of F. I have print IP, CP, and FP. What is inside the IP is address of I, and star IP, star CP, and star FP is the value. So IP, CP, and FP store the variable value. Suppose you want that pointer address. So you have to write here address of IP, address of FP, and address of CP. This is the address of pointers. And every time when I compile my code and execute, so memory address will got change. So this is every time not same. Suppose I will do something change in my code, so everything is reshuffle. So write down these all things. So one more thing. So here I have written code and enter. So this is. So one more thing you can do for repeated tasks, you can use user snippets in setting. You have to go setting and user snippets, then CJSON. Inside that you have to write down this code. So take snapshot of this code. Yeah, take photo. So here you have to write whatever the short name prefix. Then directly it will print this data. So title is difference between integer pointer and character pointer. So character not hash. It's in Python. So suppose my data is like this way. So I will draw first 4 byte data. 0 0 0 0 0 1 0 0 0 0 0 0 0 0 1. What is the decimal value of this? 258. Okay, so this is my starting location is 1000. So this is 1001. This is 1002. This is 1003. Suppose I will take integer pointer, and this is my I data. I is equal to 258. So I have stored the address of I in the integer pointer. The integer pointer will store the starting address, and integer pointer will point to 4 bytes. Suppose I will take one character pointer. So here also I store the address of I. So address of I whenever we store, so our starting address will store. But character will pointer will point to 1 byte only. Inside the character pointer we are what we are storing? Address. So address is 4 byte. But whenever character pointer is pointing to only 1 byte, it will not point to complete 4 byte because character is store 1 byte data only. Then I will write down the code. First write down this in book. Draw this. Integer I is equal to 258 and integer pointer character ch. No, I will directly take character pointer. IP is equal to address of I. CP is equal to address of I. So I have taken one integer I is equal to 258, one integer pointer, one character pointer. In both I have to store the address of I. So starting address of I have stored. Now I will print star IP is equal to percentage %d and star CP is equal to percentage %c. I will print in the decimal format only percentage %d. Then what is star IP and what will be my star CP? So here what will be my star IP and what will be my star CP?
Thousand
Why?
address of IP, right?
Here
So
star IP.
IP is star assigned to address of I, right?
Here star IP. If I will print IP and CP, then it will print the address.
Mhm.
Star IP will print the value, not address.
Value of that pointer. Okay. Yes. So it will be yes 258.
Yes, here 258. And what will be the star CP?
It should be same because see address of I. CP is equal to address of I, right?
CP is equal to address of I, right? See in your book. Okay, again I will draw fast diagram.
Yeah, it's 1000. Yogin.
Not 1000. 1000 is the address. We are not printing the CP, we are printing the star CP. How many bytes of
Two.
data store in? Yes, exactly.
Okay.
Character pointer is pointing to only 1 byte.
1 byte. Yes, yes.
So here is the data type is character.
Yes, yes.
Here it's 2 and IP will be 258. So my this character pointer is store address of I and address of I 1000. Suppose I will print here CP and IP. At that time it will be the address of
Yes, yes. Thousand,
this.
thousand.
Yeah, so 1000 is for example, it will be any random value.
Any random value, yes.
Random address it will print. But here we want data. So data in the IP will point to 4 bytes. Okay. Suppose I will do here star CP is equal to A. Now what will be my value of star IP and star CP?
First, it remains same as 258 and 2. Then it will print the value.
Here is 258 and 2. Now from here star CP is equal to A. And what will be the output here?
258 and 2.
Here we
Sorry,
have a
A.
here it's 97. A means 97.
Yeah.
So what? 0, 1, 1, 0, then 0, 0, 0, 1. This is the binary of
Yeah.
97. So it will change this 1 byte data, this location. Now this is A 97. This is right because 97 is modified. What will be the star IP? What will be the
Mm.
97 plus 256? It's 353. It will print. So here it's 1. So it's a 4 byte data.
Mm.
And here character is pointing to only 1 byte. Suppose I will change my 1 byte first byte. So it will affect on all the bytes, 4 bytes. Okay. So 4 bytes, 1 byte data I have changed here. Okay.
Yes.
Then I will run this code. So here it will give the warning, ignore the warnings. Output is 258, 2, 353 and 97. Next 46.c working on little endianness and big endianness. Everyone know what is the little endianness and big endianness?
It's related to MSB and LSB.
Yes, exactly.
From
Okay. So this is my LSB and this is my MSB. So LSB this is the least significant bit and MSB this is the most significant bit. Suppose my address will starting from LSB to MSB. So like this way. So this is called little endianness. And suppose my range will starting from the right to left. So this format data is stored like this way. So this is most important question for in embedded interviews. What is exactly the little endianness, what and big endianness, how our data will store, and how to find our data is in the little endianness format or big endianness format. This is 1000. This is 1001. This is 1002. This is 1003. This is 1004. This is not usable. Okay. So first question is, what is little endianness and big endianness? So little endianness is our data is starting from LSB to MSB. This is called little endianness. Suppose our data will start from MSB to LSB. This is called big endianness. So how to find our data our in memory is storing the little endianness format or big endianness format? So what we will do, we will take one character pointer, and inside character pointer we will store the starting address. Address will store in the this format: 1000, 1001, 1002, and 1003. Address range is same in our RAM, but our 1 byte data will be starting from the highest location. So this is the difference only. Like this way our data will store, and LSB format this way. What we will do, we will take one character pointer and store the starting address of both. That means, suppose I will take my integer I is equal to 1, and now I have to check this my data 1 is stored into the I is little endians or big endians. What I will do, I will take one character pointer, and CP is equal to address of I. So this is my I and this is my character pointer. I have stored the starting address of I in my character pointer. So what is the starting address? 1000. Now I will check star CP is equal to 0. Then it's big endianness, and star CP is equal to 1. Then it's little endianness, because character pointer is pointing to only 1 byte, and here I have stored the value 1. So I am checking here. First I am taking the character pointer address of I star CP is equal to 0. Then my data is stored in the MSB format. Star CP is equal to 1. Then my data is stored in the LSB format, little endianness format. Generally our data is stored in the little endianness format in the Motorola. uh, so there is the two segments. For your knowledge purpose I am telling you. So one is the Intel and one is the Motorola. So in the Intel, it's storing LSB to MSB, little endianness format. In the Motorola segment, data is stored in the MSB to LSB format. So if you will use your controller, at that time you have to check your data is in the Motorola or Intel format. Generally our microcontroller is came in the Motorola format, its data is stored in MSB to LSB format. So we will write down this program. So interviewer will ask you question how our data will store in the MSB and LSB. So one more example I will tell you directly. Suppose in interviewer will ask our data is like this way, X data. So this is my 4 byte data. Is stored in the LSB format. You have to convert into the MSB format. How? What will be my output? Write down this data in the format of MSB.
8765 like this. 432.
87654321. Any other? So this is the tricky question. LSB, so it store 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. MSB, so 7 8 will become here. So here not 8 7, it's 1 byte will be shipped.
Yes, 78.
7 8 5
5.
6 6 3 4 1 2.
Yeah.
So note down this. This is the tricky question every interviewer will ask in the MSB and LSB, little endians and big endians format. Any questions in this?
Yogin, why it is shuffle? 7856.
78563412.
Mm,
So in LSB format, here my 12, here my 34, here my 56, here my 78.
yes.
In MSB format, data will store like this way: 12, 34, 56, 78. So when we will print, so our data is like that way: 78563412.
Yes, yes, understood.
Data will store like this way, but whenever we use
Print.
at that time, it will always use the left to right format when we have to store and anything. But in the
Yes.
memory is storing like this way, 1 2 3 4 5 6 7 8. So our highest location will get the 1 2, then 1002 like this way. So our 1000 location get the 7 8 data in the MSB format. Okay, then write down, then I will write down this program. Don't write down this, I will write down in program only these things. We need to do integer I is equal to 1, character pointer. Character pointer is equal to address of I. If my star CP is equal to 1, printf little else printf big. My OS is in the format of little Endian S. The Windows is using the Intel format. Okay, that's it for today.